Hey everyone. All right, so we're going to do Notes 9 systems of equations, and they're going to be linear and quadratic. So if you remember, linear is y equals mx plus b, and quadratic is some form of ax squared plus bx plus c. Okay, whether it's factored or in vertex form, it's still quadratic. So what's going to happen with systems is you're going to have two or more. And so there's a couple of different ways to solve it. So the first way is by graphing. So when you graph, you can look at a picture and tell how many solutions there are. And there's actually 3 different kinds of solutions you can have. So the first picture, you can have 2 solutions. And the reason for that is because if you remember from systems, you're looking for where they intersect. So here, for the quadratic and linear, they intersect at 2 places. Okay, so for this particular problem, you see that we have an intersection on the left and an intersection on the right. And then you would identify what that intersection is. So for this one, we would have -2, 1, 2, 3, 4. So we have one intersection at -2, 4, and another intersection at 1, 1. And so those would be your solutions. So when you have an input of one of those, you do get a solution that works for both equations. So then the second one you can have is one solution. So that means it intersects only one time. So if you're looking at the picture, you can see the example, it only hits the parabola once, and in this case it hits at -1, +1, and so that would be your solution. So then you could also have no or 0 solutions because they don't cross at all. So if you look at the picture, you can see that the parabola is here and your line is right here, and they don't intersect, they don't cross, so you're not going to have any kind of solution. Okay, so graphing is our first method. Our second method is substitution. So we have a few steps. So the first one, blank one of the equations for one of its variables. So we're going to solve, if I can spell solve correctly, solve one of the equations for one of its variables. So if you are following along and paying attention, this means that you're going to take one of the equations given to you. So we're going to solve for one of the equations that we are given. It'd probably be easier to solve for the linear. That's pretty much the one that you're going to want, but sometimes you might have the quadratic set up for you. So the second one is you're going to substitute. So substitute the expression from the first step into the other equation in order to solve for the other variable. So there's a couple ways to substitute. So, this isn't just the only way we need to do it. It's just very general guidelines. So then number 3, we're then going to substitute the answer from the second step into one of the original equations and solve. So it's pretty similar to what we talked about with systems before, but now the only difference is we have a quadratic instead of an equation, like a linear equation or an inequality. Okay, so we're going to do a couple together. So page 55, we're going to take a look at an example. So we have y equals 2x minus 4 and y equals x squared minus 4x plus 1. So you can see that it's telling us to do substitution. Okay. And if you remember from systems before, if you have y equal to something and then another y equal to something, these are the same y's. So we're going to set the equations equal to each other. So we did that a few times with linear equations when we had the systems. So we're going to do that here as well. So we're just going to set them up, set them equal, because if they both equal y, then they have to equal each other. And then we're going to move what we need over. So minus the 2x, add the 4, so we get 0, x squared minus 6x plus 5. Okay, so I'm going to rewrite it so it's on the left. Plus 5. So at this point, because we still have a quadratic, we still have this square right here, we're going to go through our steps and see what we need to do. Can we factor? Can we do square roots? Can we do quadratic formula? Can we do any of that stuff? So the first thing I'm going to check is, can I factor it? Okay, so we're going to check factoring first. It doesn't look like I have a GCF. Okay, so we're not going to do that. We're just going to see if factoring works, because if it doesn't, then we have to move on. So I have a minus and a minus. Factors of 5 that add to -6. Well, factors of 5, we only have 1 and 5. So if it doesn't work, these are the only ones we have. So we have -x minus 5x. That gives us what we need. So we can then split and solve. So this is good review of how to solve by factoring, because this is what we're going to do for our assessment. You'll need it for your final. So when x is 1 or x is 5, then that's where they intersect. For the x value, we get a solution. However, we are not done. That says 51. We are not done, because now we need to take this and substitute it back in onto one of our equations and see what our y value is. So we need to do that for both of the x values we have. I'm just going to plug it into the linear one because that's what's easier. So 2 times 1 minus 4, and then y equals 2 times 5 minus 4. So this is actually -2, and then this one is 6. So we have an intersection at 1, -2, and we have an intersection at 5, +6. And we can always graph these. I mean, one of the steps is graphing, so you're going to see how that works. But that's how substitution works. It's pretty straightforward. So we're going to do it again. Okay. So again, example 2, we're going to solve by substitution. Okay. We have y equals and a y equals. So again, we can follow the same pattern we just did. If you don't have a letter by itself, then you need to make sure that you are trying to get a variable alone. Okay, so don't assume it's always going to be that way. You need to make sure you're moving things around how you're supposed to. Okay. So I plugged everything in, and now I'm going to move my items over. So all this is getting moved over. So I have 0, -x squared, minus 3x, and then the 5's cancel. Okay, so I'm going to rewrite it. So I like my variables on the left side. Okay, so this is what I have, -x squared minus 3x equals 0. So now, again, go through your list of what you can do. So you should always try factoring first. So do you have a GCF? And we actually do here. It's -x. So if I take a -x out, I should have x and then +3 on the inside. Okay, so we actually, this is factored already. We don't have to do anything else. So we're just going to split and solve. So -x equals 0 and x + 3 equals 0, which means that x is 0 or x can be -3. So we're going to take these values, 0 and -3, and we're going to plug them back in. And again, I like to plug them into my linear equation. Okay, so y here is going to equal -0 plus 3, or no, it's +5, sorry, +5, +5, and y is going to equal negative, parentheses, -3 plus 5. So then we should get 5, and we should get 8. And so the final answer that we get here is when we plug in 0 as an input, we should get 5. And then when we plug -3 in as an input, we get 8. Okay, so those are the two places that it intersects. They may not always intersect at two places, so just keep that in mind. All right, so example 3 is a graphing question. So solve the system by graphing below. So graphing. So we know how to graph linear. We have our m and we have our b. So m here is -2 and b here is -3. So I can go to -3, put a dot, and then it's going to be down 2 over 1. So I can also go up 2 to the left 1 and get the rest of my points. And again, you're graphing by hand, so you need to be very careful, because if you don't graph correctly or you graph sloppy, then you're not going to see the intersection you want. Okay, so now we're going to graph the quadratic. And so when we talked about doing this, we did the AOS, okay, which is your opposite b over 2a. This is stuff we've already talked about. So opposite b over 2 times a should give me a -1, -4 divided by 4. And then we're going to plug that in to get our y value, so we can get a vertex. So 2 -1 squared plus 4 -1 minus 3. So y here, 2 minus 4 minus 3. So 2 minus 4 is -2. Minus 3 is then a -5. So my vertex would be at -1, -5. See, 1, 2, 3, 4, 5. And my AOS is right here. Okay. So now we need a table of values, which we have talked about before, okay, of how to do. So I want you to go ahead and get your table of values so you can graph your parabola. So go ahead and do that now. All right, so here's my table of values. So -3, 3, 2, 3, then -2, -3, 1, 2, 3. I have my vertex 0, -3, and then 1, 3. That's all that'll fit on my graph here. Okay, so then if you do your graph right, you should see an intersection. If there's an intersection, you should see one. So it looks like we have an intersection at these 2 points on our graph. So it looks like there's one at -3, +3, and then it looks like there's one at 0, -3. So you should always check your answers, because you have x's and y's here. You should check to make sure that these work, because you shouldn't just assume that because you graphed it's automatically correct. So we're going to check using the calculator as well. So I pulled up my calculator. I'm going to clear out what I don't need in here. Okay, so then I'm going to put in my equations that were given. So -2x minus 3, and then 2x squared plus 4x minus 3. I'm going to adjust my window by doing zoom 6, and my graph should come up. So to find your intersections using your calculator, you're going to do second, trace, and then we talked about this the other day using the intersect option, and you can find your intersection. So I'm going to go to my first point on the left, get as close as you can to where you think the intersection occurs, and hit enter until you get your intersection. And we do get a -3, +3, which is our first point that we listed. And then we're going to do it again, second, trace, down to intersect, and then we're going to do the one to the right. Get as close as you can. That looks pretty close. I'm not sure what quite happened. Let me try it one more time. I may have not have chosen the right option. Okay. My intersection is 0, -3. Okay, so that's how you can check it in your calculator. So this last example here, example 4, it says solve the system by graphing. I want you to try to do this one on your own, because you know how to graph. That's not new. It's picking out the answer. So I want you to graph this one on your own using what we've talked about. So go ahead and do that now. All right, so here's the graph for example 4. You can see the purple line is my linear, y-intercept of 4, negative slope, so it's going down to the right. And then for my quadratic, you can see my AOS goes through -1, and then my vertex is actually at +3, so it's included in my table. and then I chose points on either side, so now I have this quadratic right here. So from your picture, you should see that you have no solution. Okay, so we're going to double check in our calculator. So if you need to pause the video, do so, but we're going to jump over to the calculator real quick. So y equals, clear out what you had. So negative 1 divided by 2x plus 4. And then the next one, you should have negative x squared minus 2x and plus 2. Okay, so linear, quadratic, you can see that it's pretty similar to what we drew in our picture, and they don't intersect anywhere, which means you don't have a solution. So we were correct. Okay, so let me know if you have questions. Have a great day.